So, hello everyone. Welcome back to another particular lecture series of our photochemistry. So, this is not the lecture. Basically, this is a question module one. So, basically, in this particular class, we are talking about some actually solving some kind of Norrish type 1 and Norrish type 2 based question, because this Norrish type 1 and Norrish type 2 based question actually comes in the examination. So I curated some questions like that actually help you to understand the Norrish type 1 and Norrish type 2 reactions. Uh, so let's begin with our question. There is a small question module. Okay. So we are talking about our first question. So I just changed the pen color. So this is our first question. Basically, I don't put it in the MCQ format. First, we have to learn that how we deal with this type of questions. Okay. So first question says that the major product that is formed in the following reaction. So we have to given this type of compound. This is a carbonyl compound, by the way, and this is the photochemical condition is given. So that means and there is a no solvent is there. So first of all, we have to check that whether this will go over Norrish type 1 reaction or Norrish type 2 reaction. So here it is clearly shown that it is going via Norrish type 1 reaction, because there is a no gamma hydrogens are available, because this is alpha, this is beta, this is gamma. So from the both side onwards. So this will obviously go via Norrish type 1 reaction. So I just simply rub it up. So Norrish type 1 reaction, we know that first step is the uh, alpha cleavage. So this both side is the same. So there will be no meaning of stereo selectivity here. This means regio selectivity here. So we can break apart by any case. So I just draw this particular compound. So this is a biphenyl. Okay. And here it is will be this only. So after alpha cleavage, this compound, after alpha cleavage, this type of compound is generated. Now, since there is a no solvent present here, so step 2 will be decarbonylation. So minus CO with the decarbonylation. Please bear about the background noises. So after decarbonylation, that means that this particular A will gone. So what should be the structure? I just simply save my time by copy pasting this, duplicate and put it here. Okay. So that means after alpha decarbonylation, so we got this radical. Now the next step will be that these two getting combined and we got our final product. Now here see 1, 2, 1, 2, 3, 4, 5, 6. That means a 6-member ring is generated. Okay. So this will be our final compound. So this reactions is this. Okay. So now let us move on to the next reactions. So the next reaction is the major product formed in the following reaction. This is also seems like a Norrish type 1 reaction. Okay. So here you can find that here now regio selectivity came into the play, because it is also a Norrish type 1 reaction. Now here there is a 2 alpha bond is there. If we cleave this particular, then what happened that here is 1 carbonyl, there is a 1 radical form, here is 1 radical, this is the 1 degree radical, that is unstable. So that means this pathway will not follow. So which pathway follow? The pathway this particular alpha cleavage takes place. This will actually show alpha cleavage, because after alpha cleavage we got a tertiary radical which is much stable, and Norrish type 1 case the radical stability is actually driven the regio selectivity. So after alpha cleavage what will be there? So this is this, this, this and this. So after this will be there. So now since here is no solvent and other kind of given, so we assume that this particular reaction is go by a gas phase reaction. And in the case of gas phase reaction, we know that decarbonization takes place. Hence, decarbonylation. That means we got finally this radical. Okay, now these two getting combined and eventually we got this compound. This, this, this. So this will be our final compound. Also, some people can say that here is the gamma hydrogen is there. See, it is alpha, beta and gamma. So it contains a gamma hydrogen. So why it is not going to Norrish type 2 reaction? If it is go via Norrish type 2 reaction, then the final product will be okay. This. So this two radical combine and here a OH is there. So this also can be possible if Norrish type 2 reaction is there, but this structure is not that much stable because there is too much ring is there. So we can say that this will be the final one. So both the possibility is there, make sure. Okay. So now let's move on to the next question. So see, this type of ring is there in the third question. So here H nu and the ether solvent is there. So that means there is a no gas phase reaction. It is also a Norrish type 1 reaction. As expected, the first process is the alpha cleavage. So first let us talk about alpha cleavage here because here tertiary radical is formed. That I hope that you now understand. So this bond will not there right now. So now it will be CH3, CH3 and here is one radical is there. Now since it is a ROH there, that means decarbonization not take place. That means intramolecular hydrogen abstraction takes place. And then a ketene formation. Now why ketene formation? See, here bicyclic ring double bond formation, that means this is not possible. That means this particular hydrogen will actually taken by this and this will radical is generated here. So that means if I duplicate this particular structure and put here, okay, so now you can find this hydrogen is come here and here is one radical formation takes place. And now these two radical combine will got ketene. Okay, so I just simply put it here only that this ketene is formed. Now ROH is there, remember. That means this attack here, this goes up, this goes down and this goes down. So what will be our final products? Final product will be this, CH3, CH3, this obviously a hydrogen is there. Here will be H. So this will be our final product. So I just remove this thing. Okay. So this will be our final product. I hope you understand. So let me check one carbon. 1, 2, 1, 2, 3. 1, 2, 3. Yes, 3 carbon is there. So this is our final product of this particular question. Now let us talk about fourth question. And if you find little fast, then I would highly suggest to slow down the video by 50% speed, and then you can check. Okay. Now here in this particular question, see here Norrish type 1 doesn't get that much visibility because after Norrish type 1 reaction, this is not that much stabilized. Okay. So if this type of system is there, so you have to find the gamma. Why is the gamma hydrogen? So this is alpha, this is beta, this is gamma. So here you can find here is a hydrogen is there. You know about the axial and equatorial hydrogen. Like one is here, one is out. Okay. So that means this will follow Norrish type 2 reaction. So let me just draw a bit. Okay. So this is the so as you know the Norrish type 2 what practically happens initially. So I just rotate this one. Okay, so that will be much more helpful. So first in photochemical condition, this particular oxygen now initially generate a radical. Okay, and then this will capture this hydrogen and leaving one radical in the gamma position. So after moving, the final product will be OH. Here is pH is there and it will be intact. There's a third butyl group here and this one radical and this one radical is generated. Now it has two different possibilities. Whether it will go cyclization or beta bond cleavage. Now if we remember about the lectures that I have teaching like in lecture 5 I guess, if you didn't remember then please go back to particular lecture and then come to the question answer series. So in that particular lecture I have discussed that that cyclization and the beta bond cleavage is entirely depend upon the substitution present in alpha bond, alpha carbon substitution. Okay. If R1 and R2 both have bulky group, then cyclization favored. That I actually discussed in the lecture 5. So here for this particular, this will be alpha carbon that is depend here. Now this particular alpha carbon have one methyl group. I think this is not prominent color. So one is methyl group and one is also a carbon bond. So that means we can say that these two groups are bulky in nature. So that means cyclization favor. So cyclization favored here, that means this to come and it will generate a final product that is this is CH3. This will form a ring system. So this will be a final product. So this will be final product of this particular reaction. Now let's talk about next question. So here also another thing. The same here also. So here also a possibility of Norrish type 2 reaction because here this is alpha carbon, this is beta carbon, this is gamma carbon. Okay. So we proceed with initially the gamma hydrogen abstraction part. So we have to first draw this particular compound. Okay. So this is the typical drawing. So this O, this radical is generated, and then it will capture this radical is there. So finally we got here a radical. This is the gamma position. We got a radical here and OH, and we got this radical. Now there is another possibility. Now what is the second step? Either it will go cyclization or it will go beta cleavage pathway. So here this will be its alpha carbon. Now this alpha carbon have hydrogen. So ideally it will go via beta bond cleavage. So this is the beta bond. That means this particular bond cleavage will be the ideal solution. However, if this beta bond cleavage, here I am writing, if beta bond cleavage takes place, then what happened? Okay. So if beta bond cleavage takes place, then here is one radical is there, here is one radical there. These two radical combined and we got a disastrous thing. And we got something, a double bond present here in this adamantate group, and this is never possible. Okay, so here although the alpha carbon contains the hydrogen group, still beta bond cleavage not possible. That means cyclization will be the final compound product. So that means this part is not possible. This will not happen. So that means cyclization takes place. I just change the pen color. Takes place. So I just simply take this, make a duplicate, put here. So although it contains two hydrogen, still these two are combined to generate a cyclobutane ring here. Just I have cleaned it for your reference. So it will be like that. OH, CH3. So this will be the final product. So in this particular example, we can understand that although we should have to follow the rule book, but if the result is not necessarily acceptable, then rules are meant to be broken. So I hope that this example will be a clear explanation of this particular ambiguity. Okay. Now let's talk about this particular. This is also a Norrish type 2 reaction. See, you might be thinking that how can I just see the particular compound and say that whether it will go Norrish type or Norrish type 2. This is because that I have practiced so much question regarding this photochemistry, especially Norrish type 1, Norrish type 2 reaction. If you are practicing so many questions, then you will easily tell that which compound will go Norrish type 1 and which will go Norrish type 2 reactions. So here also you have to find this, there is a trend there actually. So when you are solving the question, so you will find the pattern, and on the basis of that you will also able to tell that whether will go Norrish type 1 or Norrish type 2. However, so this is also alpha, beta, gamma. So here you can say why not this beta gamma, because this will make things complicated, and in reactions the thing will not that much complicated. So here the gamma hydrogen is there, so take it, So what is the first intermediate here? Already we have discussed so many questions. So this will a radical is formed in the gamma position, pH, OH. This is a gamma or radical is formed here. Now this is the alpha carbon. You know, see that alpha carbon contains bulky group. This is methyl and this is this particular one, but both are the carbons. So that means cyclization is the only option, and hence it will go cyclization, and finally it will be the same OH, pH, there is a CH3 is there. So this will be like that. Okay, now let us move on to the next question. So this is also an interesting and important question. Like many times it is come here. So this is alpha, beta, gamma. Alpha, beta, gamma. So this gamma is not that much accessible. So this is a Norrish type 1 reaction, and you can find Norrish type 1 reaction because after the alpha cleavage, okay, the radicals are stable or not. So here, see, if we go alpha cleavage here, this is a Norrish type 1 reaction. So that means what happened, that this particular resulting radical is stable because of the secondary radical. Okay, so we just draw this thing. So this will be the final product after alpha cleavage. So this is the final one. Okay. So after that, since this H nu having no other solvent there, so that means we assume it is a gas phase reaction. Gas phase reaction always decarbonization. That means it will go, this will get eliminated. So this will be the radical formation. Now you see here it is a cyclopropane ring, and we all know that cyclopropane ring are very strained one, very strained. That's why in photochemical condition this will go breaks apart. So finally we got here radical, here radical, here radical, here radical, and this. So these are combining to get our final product. This. So this is the final product. Okay. So this is the final part of this particular reaction. Now let's talk about our MCQ is there. Okay. So this is also looking like Norrish type 2 reaction. The site is same, but we just move on to this particular pathway. So first will be the gamma hydrogen abstraction. So after gamma hydrogen abstraction, what happened? This will be the structure. This will be OH, pH, and here a radical is formed. Now, as per the options, okay, so that means there is a beta bond cleavage takes place. Although this alpha carbon contains 2 CH3, but still this particular bond breaks apart. Okay, because as per the options, so we just simply breaks this particular beta bond. So what happened, let we see. The drawing is not up to the mark. Okay, so this having this bond, then this one, this is the OH, pH, here a radical, here a radical form, here a radical, here a radical form. So these two combined. Okay, so what we get finally? We get Oh, okay. pH and here a double bond. So that means this will go tautomerize to get the carbonyl back. So we just simply back this particular carbonyl. And now you have to find here. This is 1, 2, 3, 4, 5. So if the so 2, 3 bond is there. So that means this will be the final option A. A is the correct. So thank you for attention.